I'm recording everything that you do in the class so that it becomes a reusable material for you guys. So when I'm teaching something, my request to each and every child in the class is focus on following the concept rather than being worried about taking notes. Okay? Everybody in the class has heard the story so many times. You are the first one. I mean, this is your first class today, so that's why I'm repeating it. Okay? Alright? Now, another thing that we need to be aware of, Vaishnavi, is that in this class is meant for making mistakes. So if anybody makes a mistake, that becomes an opportunity for us to learn something. So never be shy, never think, shall I say it now? What will others think? No. Keep those apprehensions aside. Because if we share things in a very transparent way, it becomes easy for us to learn things faster, okay? Treat me like your parent, treat me like your uncle, treat me like your guardian, whatever it makes you comfortable. But never be shy, and everybody has my number. I mean, if you are having your own phone number, WhatsApp, if you have a question that you're struggling with, don't hesitate, send it to me. I will find out a time and respond back to it, okay? Alright, so let's do a quick roll call and we'll get started. So I see some of the kids are still missing. Pranit is not in the classroom yet. Where is Alekhya and Tansi? Tansi, you're joining online as well?
Oh, Alekhya's with me. We were on the same place.
Alekhya is with you. See, we got other friend for you in the classroom. Her name is Vaishnavi and she is missing you guys. Okay, no, I'm just kidding. But yeah, it'll be better whenever you guys get a chance to come to classroom, that will be better. I'm sorry. Sorry, beta? Alright, so let's get started now while other kids are joining. So we have Nikhil, Ritika, Riya, Shiv, Shravya, Tansi, and with Tansi we have Alekhya as well, and then we have Varun and Dev, Dhanvir. Alright, so let's get started. What are we going to learn today? Do you guys remember? Does anybody know? So we actually started with, so Davik, I will need your help to close the garage door so that the AC is effective. Oh, thank you so much, sir. Below one, yeah, below one, yeah, that works. Thank you. Thank you so much, sir. It's only for my kids, not for parents. So we actually started talking about quadratic equations. We learned different techniques for solving quadratic equations, right? And then we just got jump started with the understanding of what is a rational exponent, what is radical exponents, and we are going to play more with it in the class today. Alright? Everybody okay? Does everybody recall what we did yesterday?
Yes.
Except Vaishnavi. Obviously Vaishnavi was not in the class yesterday, but anyways, so whatever we did yesterday, I uploaded the video of the class. You can just go through it once just to judge whether these things are making sense to you or not. If it doesn't, let me know. Alright? So that will be the way forward for us always. So this video is recorded and uploaded in YouTube, not because I have any plan of becoming a branded YouTuber. It's only for my kids to use that as a reusable artifact. Yeah? I mean, I don't mind you guys subscribing my channel, but I'm saying the intent is different. Alright? Okay. So anybody having any doubt with respect to what do we mean by radical exponent or rational exponents? From the class who were there yesterday. What does silence mean? Yes or no? What does silence mean? I was asking, whatever we tried understanding with respect to what is radical and rational exponents, what is the understanding of that? What do you guys recall?
It's like rational exponent, it's like fractional, it's just equivalent to root. But it's hard to just it's not actually like multiplying by itself, instead it's the opposite, it's like square, it's rooting itself.
Okay. So let me explain in a very simple way. So if I have 4 to the power 3, this is called exponent. Everybody knows that. Here 4 is my base and 3 is the power to 4. What does it mean is 4 is getting multiplied by itself 3 times. Yeah? Everybody clear? Now, if somebody says 6 to the power 8, you know that you are multiplying 6 by itself 6 times, 8 times. That's what exponent means for us. Correct? And then we looked at some of the basic rules of exponents where we talked about multiplication and division of exponents. Let's say if I say 4 to the power 3 multiplied by 4 to the power 5, what does it become? 4 to the power 8? Yeah. If your base is the same, your power gets added. Yeah. And we saw that yesterday. When you watch the video of the class, yesterday's class, you'll be able to do a recap of that as well. So it becomes 4 to the power 8. I will not get you guys confused. I will give you a generic rule. I'll keep that in the corner so that I don't delete it. If I have x to the power a times x to the power b, this becomes x to the power a plus b. This is my generic rule that we'll follow. Yeah? Everybody with me? Dave, no problem, right?
No, yes, sir.
Okay. Similarly, if I am trying to divide exponents, 4 to the power 3 divided by 4 to the power 2, it becomes 4 to the power 3 minus 2. And we can see that by normal calculation, right? So this becomes a generic rule for us, saying x to the power a divided by x to the power b equals x to the power a minus b. And these are the things that you guys already know. I'm just doing a recap of that so that when we go to rational exponents, we can relate to these formulas or rules. Tansi, no issues?
No, yes.
Alekhya with me?
Yeah.
Dhanushri and Riya, no problem, right? I'm assuming silence is yes. Ritika, no issues, right?
No, sir.
Okay. Now, the third rule that we saw was x to the power a in bracket to the power b becomes x to the power a times b. This is the third rule of exponent. Everybody with me? Sahid? Okay. Shravya with me?
Yes, sir.
Okay. And again, we saw why it happens that way. This is a generic rule. We have the three generic rules with respect to exponent that we have to keep in mind. Now, if I say x to the power 1 by 3 multiplied by x to the power 2 by 9, what happens? Any thoughts? Just give me the approach. Don't tell me the answer. I'm not interested in the answer right now. If I have x to the power 1 by 3 times x to the power 2 by 9. First of all, this is what is called rational exponent, because my exponent or the power is in the form of a rational number. Yeah? Now, what happens when I do that? My generic rule, my basic rule, that doesn't change. Be it rational exponent or irrational exponent or whatever it be, my basic thumb rule for calculation would not change. Dave, you agree?
Yes, sir.
Sarah and Neil, okay? So, what I'm saying is, first of all, we know about the exponents and the basic rules that we saw yesterday. Now we are extending our understanding to go to radical or rational exponents. So, this is called rational exponent. Meaning, when your exponent is in the power of a rational number or a fraction for that matter. This is called rational exponent. And how will this work? It will work based on the same rule of thumb. I have x to the power 1 by 3 times x to the power 2 by 9. So my base is the same and I have one exponent here, one exponent here. So multiplication rule for exponent, it will follow and it becomes x to the power 1 by 3 plus 2 by 9. Now, if you guys know how to add the fractions, it's easy peasy, right? Nothing to worry. Yeah. So when you see something complicated like this, don't get stressed out, because one thing that will not change for all of us is the basic rule. The concepts don't change every now and then. Problems could change. So as long as you are sticking to the concepts, you have no doubt about the concepts, you will have no struggle with that. Shiv, are you with me?
Yes, sir.
Any doubt, don't hesitate, don't be shy. You can shout back at me saying, sir, this is not clear. Okay? And that's for everybody, not only for Shiv. Now, there was another term that I referred, saying radical and rational exponents. So right now I'm not going to the calculation part, I'm just trying to make sure that our understanding of the concepts is crystal clear. Okay, so one is radical exponent, second one is rational exponent. Let me use the real set little better. This is radical exponent, this is rational exponent. What I'm saying is, you don't have to learn both of them, just learn one. Because second one is just a repetition difference. Now look at it. If I say x to the power 1 by 2, I'm saying this is a rational exponent because my exponent is in the form of a rational number. Yeah? I will put the same thing in a different way. I put a square root of x. This 1 by 2 is nothing but a square root. So this representation is called, what did I do? Yeah. So this is called radical exponent, meaning it's just a different representation style. If you express your exponent in the form of a rational number, that's called rational exponent. When you represent it like this, it's a radical exponent. Does it make sense to everybody? If I say x to the power 1 by 3, that is as good as root cube of x, and you can represent that in the form of this. Okay? Now let's start toying with these concepts. If I say x to the power 2 by 3, how would you represent this in radical form? Any guess? Yeah?
X, cube root of x to the x squared.
Okay, I heard you. Let's see what Shiv says. Yes, Shiv.
Sir, would it be cube root because the denominator is 3 and cube root because the denominator is 3 and then, so it would be cube root of x multiplied by 3. Sorry, I mean 2.
X multiplied by 2. Why so?
No, cube root of x multiplied by 2.
Okay, no, that's what I'm saying. Okay. Must have any thoughts. Put any random thought, that's okay. It's okay to go wrong, that's fine. Cube root of x squared. Okay. So now, what we will do, okay, so everybody here, I think everybody is kind of giving me similar clue, and I'm not saying that is wrong, everything is right. I will actually decode this, it's like peeling onions. If I have something like this, whatever I have in the denominator, that is my nth root. If I had 3 in the denominator, I will put this as I will put x like this is my base, I'll put the x here. Whatever was the denominator, that goes as that nth root of that. And then whatever I have as a numerator, so say to your point, it will not be 2 times x, it will be x squared. See, if this was not there, what was it? X squared, right? That's what it is. I had by 3, that is nothing but a cube. So if you ever see a term saying a to the power 2 by 9, what we are saying is, this is my nth root. My denominator is representing my nth root, and this is my exponent. Shravya, Rehan is not there. Okay. Ria. Am I making sense here?
Yes.
So, a clear guideline for all of us to follow is, whatever is my denominator is my nth root, and this is my exponent. That's how I'll treat it. If somebody says 16 to the power 1 by 9, okay, it's 16, 9th root. If somebody says 16 to the power 2 by 9, that means 9 is my nth root, 9th root, and whatever is my numerator, that is my power here. And then I'll calculate this. I want to see some confused faces. Nikhil, am I making sense or getting you confused?
No, sir, it makes complete sense.
Ritika with me? Okay. So you guys disappointed me. I wanted to see some people confused. I was not successful. So this is so two things. One is the basic thumb rule for exponents remains the same no matter. Davik is finding some of the jokes funny. My jokes are not funny actually. These are called dad jokes. Not a very open quality jokes, but we'll deal with it. So one thing is the exponents rule that will keep with us. And second thing is when we are looking at radical or rational exponents, we have to always look at the denominator of that. Okay? If somebody says, let's say, x to something like this, 4, convert this into rational exponent. This is my denominator of the rational exponent. This is my numerator of the exponent. Yep. This can be represented as 4 by 10. Yes. Somebody had a question. Who was it?
Sir, I just realized on the x raised to the power of a raised to the power of b, it says a times x raised to the power of a times b. So, what would x to the power of a divided by b?
This one.
No, the third one. The third one, what would be the opposite of that?
X to the power a instead of what b like this.
Yeah.
You are making me think. Now let's look at it. For me, it doesn't really matter. X to the power a to the power b. Now, whether it's b or 1 by b, 2 by b, 9 by b, I don't care. For me, it's one thing, it's another thing. It will become x to the power a times whatever you have here. Because I will always stick with my basics. My basics would not change. Does it make sense?
Yes, sir.
Okay. Everybody making sense? And trust me, I was not prepared for this question. But then my only savior was my basic concepts. Now, see, I have no obligation here with the rule saying it has to be natural number always. A and B could be a fraction, could be decimal, it could be anything. Any number that you can imagine. My formula, see, 3 times 4 is 12, 5 times 6 is 30. How do you arrive at that? That approach doesn't change. Numbers could change. Approach doesn't change. That's what I keep emphasizing, and I will emphasize it one more time even if you guys get tired of me. Yeah?
Is it possible to have a negative rational exponent?
Yeah? We'll look at that. So now let's look at it. So let's somebody was raising hand. Who was it? I thought somebody was trying to say something. Okay. So now let's look at some of the basic things like what we saw just now. Okay. If I say x to the power 2, everybody knows what it means. Are you with me, David?
Yeah.
If I say x to the power minus 2, what does it mean?
Would that be 1 over x squared?
Same? Agree? Okay. Now, I don't know what it means. I only know some basics. I'll apply the basics. See, when I had x to the power minus 2, how I can write this? This is nothing but 0 minus 2, right? Which is nothing but x to the power, if I relate it with this formula, x to the power a minus b is nothing but x to the power a divided by x to the power b. That means x to the power a, which is 0, divided by x to the power b, or 2. What it became? Anything to the power 0 is 1 divided by x square. Yeah? So what we are seeing is, if I had a power minus 2, when I wanted to knock off minus part of it, it came down. If I had, let's say, okay, now, if I had x to the power 2, and I want to write this in a fraction form, if I bring it down, what will it become?
X power right?
Yeah. So simple convention. Again, I can prove why it will happen. Okay. Simple convention is if you are moving something from first floor to ground floor, you are changing the sign. Yeah? Ritika with me, beta?
Yes, sir.
Nikhil, no confusion?
No, sir.
Okay. So let me put that also as a rule so that it sticks with us. So this table is becoming bigger for us. More, see again, these are the things that will come with practice, but we are just trying to wrap our head around this one. Or x power minus 2 equals 1 by x to the power 2. And minus 2 is just a number. You can change it to 10, 20, 100, 1000, million, billion, whatever it is. The same thing. Now, other thing that we saw was x to the power, let's say 1 by 2. Where I'm going? Okay, so we saw this one. So if I have a rational exponent, it can be represented in the radical form like this. This is what we saw. So let me put this also as a rule for you guys to take a picture in your mind. If I have x to the power 3 by 9, it is nothing but, if I represent that in radical form, I will say, okay, this is my denominator, which is 9th root, and x to the power 3. Everybody clear?
Yes, sir.
Now,
Yes, sir.
when you have a teacher who doesn't get happy with what he does, what will happen here? Now what are we talking about? We are talking about, and I am saying represent this in radical form. See, it's both way traffic, okay? You have to make me think, I will make you guys think. Now represent this in radical form. How will you do it? X to the power minus 9 by 4. Yes.
Okay, there's two ways. The first one, through that number. So it would be 4 root. Radical sign 4.
Write it in your notebook and show it to me. Because a lot of things that you draw in air, I will not be able to make out. Try it. Go wrong, it's okay. Is everybody trying on the screen as well? Dave, Shravya, Nikhil. I am saying represent this in radical form. X to the power minus 9 by 4.
Can I try?
Everybody has to try.
I think it's 1/3 of x to the power of 9.
4/3.
4 root of x to the power of 9. Oh no,
Oh,
it's
sorry.
like, yeah. No, yeah, fine.
These two.
Another way. Another way. Without a negative sign. Let's see.
Just one of the
Minus in the same.
this like without the negative sign.
Because I don't want to see negative signs.
This one is. You want one with negative sign?
Yeah.
This one's without this one. This one
Okay, we'll verify. Okay, we'll come back to it. All right. Yes, Dave.
Okay, so the way I consider it is, since we know first it's a negative sign, we know we have to put it 1 over whatever the radical will be. So I could write 1 over, and since the 4 is in the bottom, I could put it to the 4 root thing with the x inside, the 9 on the outside. Yeah.
Is that what you're saying? Okay. This is one of the answer. I don't know whether it's right or wrong, but yeah. Okay, Ritika. What is the answer, beta?
Wait, I forgot to like include the buzzers like that. Like x is like the negative sign. Like,
Oh, okay. Maybe I was not very clear when I was doing it. Yeah. Yes, sir.
I said that it would, because it's negative, it would be 1 over the next part.
Mhm.
So it's 9 over 4, so it would be 1 over the 4th root. So like cube root is then 4,
Mm-hmm.
or the little 4 and then x raised to the power of 9 inside this cube. the root.
Okay.
And all
Yeah.
of that is underneath the.
Right. So see, I mean, if you ask me whether did I think about this question, no, it came on the fly. I'm just thinking or grappling with it to figure out, based on the understanding that we have, what are different scenarios that we could come across. And there was no scenario. First, again, like many of you said, if you have a negative sign, that simply means this guy is going to move downstairs. Okay? It becomes 1 over something. So this is where you got rid of the negative sign, because more the signs, more the complication, more the numbers, right? Our job is to make things simpler, as simple as we can. So first thing is negative sign you knocked off. Now you can say, okay, fine, this is 1 over x to the power 9 by 4. Now you know what it means. If you have to replace that in radical form, you know what it means. So this is 1 over x to the power, and this is by denominator, so that is the nth root, and this is by numerator, this is what it is. Yep. So again, whenever we have any problem, our first attempt is to decode that, make them as simple as we can based on the rules that we know, and then so now question to everybody except Vaishnavi. Do you guys want me to repeat my story one more time? The story that I bored you guys so many times with? The RAN thing? Okay. So I have a very unique formula that I keep insisting all the kids to follow. And I say the story around that is RAN. If somebody goes for a relay race or any kind of sprint event, who wins the medal depends on how he or she ran. And now when you decode this, R stands for read, A stands for analyze, and N stands for Nike. What is Nike's punchline? Just do it. And this is not a formula given by anybody. This is what we have invented in this class. So here, what I mean by this is, whenever you have a problem to deal with, don't jump on to solve it. Read the problem couple of times, question couple of times, then analyze. When you put your thoughts together, okay, this is a problem, this is what it is asking me to solve, and this is how I'll go about it. What are the things I know? Put your complete thoughts and the blueprint around that problem, and then Nike. Then you do it. Where we go wrong is, we pick a problem and start solving it. That is where the chances of going wrong is more. So I have bored everybody so many times by stating this thing, but the only intent here is, I will keep on emphasizing this over and over again to each one of you, just to make sure that it becomes a habit. Because in the exam, you will have limited time and a number of questions to solve. If you waste even 2 minutes in one problem going in the wrong direction, that 2 minutes that you are losing, that will compromise the chances to solve 2 more problems, which will impact your score. Yeah? So, no other choice but to follow that. Okay? Alright? Are we all clear so far? Shravya, Tansi, Alekhya, Riya,
Yeah.
Ritika. Okay. And I have a praise for Nikhil. I'll tell you why. Nikhil and Dhanushri, these are 2 kids who reach out to me whenever they need some extra clarification, some extra doubt. Okay. I want you guys to behave the same way. Whenever you struggle with something, some problem, let me know. Either by sending me a message directly or through your parents. Any which way is okay. If you let me know, on Saturdays and Sundays when I finish my morning classes for the kids back in India, I keep a 30-minute window for you guys. Okay? If anybody has any particular problem or concept that you want to clarify, let me know 1 or 2 days in advance. I'll make sure that I get into a call with you guys one-on-one, solve it there. So, there are 3 opportunities that we have in the class. One is whatever we do in the class, that, and then the video to rewind whatever we did, and then reach out to me for anything that is kind of making you worry. Okay? And in my childhood days, I don't think I have ever understood any concept in one go. I was not as intelligent as you guys are. So I have to go through those concepts multiple times. So I feel that is normal. That happens for all of us. So if there is any question, let me know. I know Ritika will have a problem because my class starts at 8:30. That special class for kids who need some help, and that will be 6:30 for her. So for Ritika, I'll have to do a different deal if she needs any help. Right, Ritika? All right. So let's move on. So what I had done was, these were some conceptual part of it that we kind of learned. Sorry, sir, I'm getting you bored, right?
No. Yeah,
That's okay?
that's it.
Okay. All right. Now, so I keep requesting parents to be in the class sometimes. So sometimes I get lucky to have some of the parents in the class. So that way, today we have a guest as well. So what I had done was, I had picked up some of the sample questions that you guys will encounter with, right? And not the questions which are made up by me. Some of the standard questions that will come across, which I picked up from Khan Academy again. Let's try doing some of them. And I would not want you guys to try solving them. First think about the approach, tell me the approach, and then solving is the easy part, okay? Nike is the easiest part of this whole journey, okay? This part I don't really care much about. As long as you are reading the questions enough and analyzing it the right way, this will always get you the right answer, okay? So let's look at one question. The question here is 3 to the power minus 1 by 5 times 1 by 3 to the power minus 2 by 5. I'll read which of the following values is equal to the value above. Let me not waste your time writing down the options. Okay? Simple thing is, this is what we have. We have to simplify this and get to a final answer. Okay? In the simplest possible form. So, again, I'm reading the question one more time for you guys. As I said, read the question again and again. If you read the question 3 times, the question becomes half difficult. Now, 3 to the power minus 1 by 5 times 1 by 3 to the power minus 2 by 5. Let's see how you are wrapping your head around this one. And tell me the story. You guys have 2 minutes. Think about it. Solving is easy. Think about it and tell me what your approach would be. Vaishnavi, do I speak very fast? It's okay? Okay. Everybody else has tolerated me enough. You are the first one today. Okay. I mean, this is your first class today, that's what I'm asking you. Varun, Nikhil, everybody trying, right?
Yes, sir.
Okay.
Yes, sir.
I want everybody to try. Go wrong, that's fine, but tell me the story. How would you approach this problem?
Sir, the numbers are different. So it is more complicated if the numbers are different.
Okay, let me read it one more time for you guys. 3 to the power minus 1 by 5 times 1 by 3 to the power minus 2 by 5. So numbers are not different, okay? And again, I will not give any clue. I want you guys to think about it because thinking is very, very important. And I'm not even going to do it, but I want you to first think about it and tell me. So do you need water? Okay. Let me pick everybody's brain. Yes, Dave, tell me.
Okay. The way I did it first is
Wait, Dave, just give me 10 seconds, okay?
Okay.
These guys are very loud. Yes.
Okay, so first I see that one end has a base of 3 and the other has a base of 1/3. I can also see both of them are negative. So for the 1/3, I can flip it so it's 3 because it's a negative sign. So then it simply becomes 3 to the power of 1/5 times 3 to the power of 2/5. And then since now they're the same basis, I can just multiply the exponent using the rule. Add the exponents using the rules. So it's just 3 to the power of negative 1/5 plus 2/5, which is just 3 to the power of 1/5.
Okay. That was quite detailed, but let me hear everybody else. Tansi, Alexia, any thoughts, beta?
answer that I got?
Tell me the answer. That's okay.
I thought it was 3 and 1/5.
3 and 1/5.
Yeah.
Okay. Shiv. Alekia got the same answer?
Yeah.
Okay. Shiv.
Sir, I got a little more complicated answer.
That's okay.
I got the because I thought the numbers are different. I shouldn't like add them, so I did like one over √3 to the fifth. √3 like the fifth root.
Okay.
3 and multiplied by 1 over 1/3 squared inside the fifth root.
Okay.
And those two are multiplied.
Okay. Varun, your answer beta? Varun, Dhanvin. Okay. Neel and Sarah. Okay. So I will give you guys maybe 2 more minutes, okay? So that you know, we can solve it and get to a common point. And again, whoever is halfway through, once you guys see me doing it, probably you'll be able to relate to if your approach was okay, or maybe you were following a different path.
Can I see it in English though?
Could be. I don't know. I mean, I'll trust whatever you guys say as long as you can justify it.
I got 1 to the power of -3/5.
Okay. 1 to the power of -3/5. So I'm not writing all those down, okay? Let me not write any of the answers, because what happens is, if I see the answers more, I'll get biased with one of them. Yes, sir. You're still working on it? Oh. That's fine. So we will. Okay. So let me ask everybody to pause. Time out. So here, now as I said, if I have a question like this, my silver bullet is this. This will determine whether I'll get the medal in the race or not. So read the question, okay? The question is 3 to the power -1/5 times 1/3 to the power -2/5. And all these are not looking so nice numbers to deal with. These are looking little complicated to begin with. So, okay, these are the numbers. I did it multiple times. Now, I think I know what it's asking for, so I don't have to read it anymore. Now I'm analyzing, I'm thinking, how do I deal with it? See, all these numbers, here I have a natural number, here I have a fraction. I have negative powers. All these are little complicated in nature. But the good news is, I have this, see, 1 to the power anything means nothing, it just means 1. Be it 1 to the power 100, or be it 1 to the power 3, or be it 1 to the power 2 billion. It's always 1. So eventually what I'm seeing is, okay, I have 3 to the power -1/5, and this anyways means 1, and this is again 3. So I can break it down. So basically now I'm seeing that, okay, fine. While it was looking like two different things, little complicated in nature, but when I peel off the onions a little bit, what I see is, this is one thing, and I have 3 to the power something, because 1 to the power something doesn't mean anything to me. So now what I have is 3 to the power -1/5 times 1/3 to the power -2/5. Can I say so? Yeah? Or if you don't want to get to that very quickly, let it be. So I will say 1/3 power -2/5. This means -1 to the power -2/5 by 3 to the power -2/5. Is that okay? This guy will never give me anything other than 1. Be it 1 to the power 1 or be it 1 to the power -1, all means the same thing. Yep. So 1 to the power anything apart from 0 doesn't give me any different answer, it is always 1. So now my job is looking a little easier. This is when I will jump onto Nike. Because see, now my job is much easier actually. 3 to the power -1/5 into 3 to the power -2/5. Okay, so let me keep one of the negative here without changing it, and let me move this guy up. What it becomes? 3 power 2 by 5. Minus becomes plus when I move it up. So I have 3 power minus 1 by 5 into 3 power minus 2 by 5. So x to the power a times x to the power b. That is x to the power 3 to the power a plus b, meaning minus 1 by 5 plus 2 by 5. That's what it is. Who all is not with me? Who all are not with me? Tansi, Varun, Nikhil, everybody able to follow me?
Yes. Yes, sir.
Riya, Dev,
Sir.
Neil, Sarah? Okay. So now, what we did, something that was looking very complicated was not actually that complicated. When we just broke it down. When we broke it down, okay, we saw that, okay, I have 3 power minus 2 by 5 and here I have 3 power minus 1 by 5. If I move one of it above, then I have everything in one place. It becomes 3 power minus 1 by 5 into 3 power minus 2 by 5, which is nothing but 3 power. I'll apply this rule. Something to the power a times something to the power b equals something to the power a plus b. Something to the power a plus b. Now I have minus 1 by 5 plus 2 by 5, which equals 3 to the power 1 by 5. 2 by 5 is plus and 1 by 5 is minus. When I add them together, I get a 1 by 5. Yep. Is it looking okay to you guys, or I am getting you guys more confused?
Yes, sir.
So all of you who are trying to find out different ways to solve it, this should give us a clear clue that it was not as difficult as it looked in the first go, correct? And how it became simple? Because somebody who is as stubborn as me, who was reading the question multiple times. Because when you, again, trust me, pick up any question on a day, just to play with math. Pick up any question, any topic, read it 2 times, 3 times. You will see that it becomes much lighter than what it looks otherwise. And interestingly, you guys will end up dealing with a lot of word problems, which are meant for getting people confused. And word problems you can decode only if you read a couple of times. Read it, note down, read it, note down, and then compare. Once you have read it enough, once you have decoded what all it is asking you to do, then you put your thinking hat. This is easy peasy. I mean, if somebody says, I don't know what is the formula of finding area of a square or a rectangle, that is not to be believed. I would not believe that. Where we get lost is when there is a big story written and we are not able to pull out the information that we need for solving it. Yeah? Make sense? You guys want me to give more lecture, or let's pick up next problem?
Yes, sir.
What does yes mean? You want more lecture or you want next problem? Next.
We want next problem.
Next problem. That's honest. That's honest and I like that. Okay, let's pick up the next one. So, next problem is a little interesting one. Okay? Now we have 2x minus 3y equal to 4. This is what is given. Okay? What is the value of, let me not write those things. What is the value of 4 to the power x divided by 8 to the power y? I'm reading the question again, as I promised. 2x minus 3y equal to 4. What is the value of 4 to the power x divided by 8 to the power y? This is interesting, okay? This will make you go beyond or go outside your comfort zone, and it will make you think. Now you think. Everybody heard the question, right? Everybody noted down. It's a simple looking problem, but interesting one. 2x minus 3y is given as 4. 2x minus 3y equal to 4. That is one value given to you. You have been asked to find out the value of 4 to the power x divided by 8 to the power y. Now you can go for a small nap. I'll let you guys think. Okay, spend 2 minutes. Then I'll probably give you guys some more clue. Save, Varun, Neil, Sarah, Ria, everybody got the question right?
Yes, sir.
Savya, Nikhil, Dave, everybody?
Yes, sir.
Okay. Yes, Dave.
Sir, ask a little bit. Should I go over it right now?
No. I would
Okay.
want you to hold it for 2 more minutes, okay? I want everybody to think, otherwise everyone will get biased.
Okay.
Tansi and Alexia, make sure everybody is breaking their head, okay?
Cool.
Yep. No, do it. And this is an interesting one, okay? So break your head as much as you can. Make sure you are not getting hurt, but keep breaking your head. Keep trying. Is it already 3:51? Okay. So we have 9 more minutes. I'll probably give you guys just 2 more minutes to think about the approach. Maybe even if you're not able to solve, that's okay. Okay, we can probably stop here. We can stop here, okay? Dave, you want to give your story quickly?
Yes, sir.
Hmm.
So the first thing I did, I looked over the question again, and I see that 4 and 8 have a common base of 2.
Mhm.
So I rewrote it as 2 to the power of 2 times x over 2 to the power of 3 times x. And then I know that for exponent rule, the opposite of division is subtraction. So I did 2x to the 2x minus 2x to the 3x. And then I realized that 2x to the minus 3x, 3y is 4.
Mhm.
So then it's just 2 to the power of 4. And after solving for 2 to the power of 4, I get 16.
Okay. That's a smart one. Okay. Everybody here. Now when you have a problem like this, Daivik, Arush, Vaishnavi, Sahit, everybody here. All the kids on the screen here. So when you have a problem like this, how do you approach? See, you are given some value here, and this one doesn't seem to have any correlation with this guy in the first go when you look at it. It doesn't come straight, okay? There's a little bit of ambiguity in the problem that we have at hand, okay? So what Dave was saying was that, okay, when I look at, let me keep this part for now, okay? Let me try simplifying this because we have to find out the value for this guy. Let me try simplifying this. If you stare at this problem for some time, what will you see that, okay, 4 is 2 to the power 2 and 8 is 2 to the power 3. So there is something common between these guys. And does it have any relationship with this? Let's see. Let's first try simplifying it. Let's first try simplifying this. So, okay, this is 2 to the power 2. This is my 4, right? 2 to the power x. Yeah? And this is 2 to the power 3, which is my 8 to the power y. So, see, simple things are always better. As simple as you make things, it makes your life much easier. See this. By looking at this question alone, it was not looking easy. But when you try to make it simple, when you looked at this particular piece, because this is what you have to get the answer for, and you found that, okay, there is something common between these guys. This is square of 2, this is cube of 2. As soon as you put that, you see a straight relationship here with this guy. This became what? This is my third rule of exponents. This is 2 to the power 2x divided by 2 to the power 3y. Now this is my second rule of exponent. X power a divided by x power b gives me x to the power f a minus b. What is that? This is already given to us. Now this is 2 and this whole value is 4. 2 to the power 4. Everyone in the world knows how much it is. Yeah? Yes, Nikhil?
16.
Yes. Correct. So I'm saying this part you all can figure out. Yes, Save. Save, you are saying something.
Sir, I was looking again and again, and
Huh?
like, I'm not. I tried turning it super complicated because I changed it on two sides of the equation to make it favorable to different goals. So like 2x. So I found the value of x by doing 4 plus 3y divided by 2.
Oh yeah, that is a longer route.
Yeah, and then 4 minus 2x divided by 3 equals y. So I did, and I turned those into the. I
Okay.
turned those exact equations into the
Right.
exponents.
And see, I'm not saying that will not give you the answer. That will get you the answer. The only problem is here time is money. Because in the examination hall, when you have to solve 30 problems and you are given 2 hours, you are given 2 hours only. It will never become 2 hours, 2 minutes also. So even if you lose 2 minutes by following a different path, so that is why this part of the whole solution process is very crucial for us. This is where you make your mind that okay, this is the path I'm going to follow. Because if you give me any problem, with my limited knowledge, I can solve any and every problem at least 3 to 4 ways. Okay, most of the things. Now, out of the 3 or 4 ways that I can figure out, there is one way which is the most efficient one. This is what this analysis phase tells you. That okay, you know different options, follow this path. That will be quick. Or if you have to fail, you have to fail fast. I mean, if one approach is wrong, you have to realize that this one is wrong as soon as you can, so that you can pick up the alternate one. Okay? So that is where it is crucial. So that's why I keep emphasizing, boring, torturing, frustrating you guys with my story over and over again. Because if you practice this, I'm sure you'll be able to save some precious time during the exam and avoid that phase of anxiety. Just unwin.
Wait, how, is that like 2 to the power of 2x minus 3y like down there?
Yes.
Or is it just 2x minus 3 is equal to 2?
2x minus 3y. This is what we got by solving this. 2 to the power 2x minus 3y. Now 2x minus 3y's value is given to us in the question itself. So we just substituted this value and we got the answer for this whole problem. Yeah? Alright. So we started little late and we lost few minutes because of the technical glitch, but unfortunately the kids from the next class will be joining. So I'll have to let you guys go little early, but then now the question that I have or the recommendation or request I have for you guys is that in the WhatsApp group I have sent few more questions. Okay, there are 2 more questions. I would want each one of you to try those questions and send me the answer. When you try it, do it in a full-blown notebook, solve it step by step like you are writing stories, and then send me the WhatsApp, send me the solution in the WhatsApp chat. Okay? Send it to me one-on-one. If you don't want to make it public, that's okay. But I want to see how you guys are approaching those problems. And those problems are also going to be following the same approach, same rules. As long as you don't deviate much from the basics, you will still be right. The approach has to be fine and the rule has to be followed. Does that make sense? Now the next 2 minutes that I have, let me check everybody. Did we learn something today or it was just a quick breeze of confusion? Yes, Nikhil?
We learned today.
Wonderful. Dhanvin, Neil, Sarah, Nikhil,
We learned today.
Ria, okay beta?
We learned today.
Okay. Save, Shravya, Tansi and Alekhya, everybody?
We learned today.
Okay, good. If as long as we learn something, I will let you guys go. Enjoy the rest of your evening. I'll come back to torture you next
Okay,
Thursday.
mister.
Bye bye. Bye bye. Bye bye.